I think that our academical 5 minutes was passed, so I think that it's time to start. From on behalf of organizing committee, I'm very glad to welcome you all in our 12th international conference IEEE DESSERT' 2022, in which this time is take place in Athens under special organizations and technical support. First of all, from IEEE of Greek section, our University of Thessaly, Greek University of Thessaly, and Special Department of Informatics for Medicine Sciences, the staff, all the staff and Academy of Military Academy in Greece, University of National Aerospace University KAI of Kharkov, Lutsk National Technical University of Ukraine, also like KAI, Leeds, and of course University Institutions of Information Science and Technology of Pisa from Italy. Today we'll start our plenary lectures, of course, and after that we will have 2 sessions during all the day, and we will have also 2 coffee breaks and 1 lunch time, so everybody can have any rest. To start, it's a honor of us to welcome it's with us Professor Kakaroudas, Vice Chair of Greek IEEE, Section IEEE, and representative for University of Thessaly. Professor Kakaroudas, thank you that you are with us.
Thank you, Professor Bardis. Dear organizers, dear researchers, dear participants. It is a great pleasure for IEEE Greece section to technically sponsor the 12th International IEEE Conference on Dependable Systems, Services and Technologies. The conference is organized by respected colleagues of the Academy, but also attract numerous researchers from the industry, as Professor Bardis already mentioned. The IEEE Greece section will always be available to support scientific and research events, conferences, and symposia from the Ukrainian College. And from the first time that we learned that the DESSERT' 2022 will take place in Greece, we have become part of it, supporting the efforts of our colleagues from the Ukrainian section. Apart from thanking Professor Bardis for inviting us to participate, I would also like to mention the efforts from the organization committee. These efforts are worth mentioning since they managed to bring to us a rich technical program of high quality under the dark clouds of war in Ukraine that traditionally hosted this conference. I strongly believe that apart from the technical part of the conference, this is a great opportunity for Greeks and Ukrainians and researchers from other countries to discuss on potential collaboration, and especially for the Ukrainian colleagues, I would like to suggest or say that hosting Ukrainian researchers to Greek universities and research centers is an opportunity for you until this war comes to an end. Apart from my greetings as the Vice Chair of the IEEE Greece section, I would also send the greetings from Professor Ioannis Anagnostopoulos, who is the head of the Department of Computer Science and Biomedical Informatics from the University of Thessaly. And we're always welcome our colleagues from Ukraine to come to our department and conduct their research here in our premises. I hope that these 3 days that this conference lasts will take your mind away from the war, and it will be a creative time for you here in Greece, and find ways for us, the scientists, to discover other ways of promoting humanity and promoting science for the human beings. Saying so, I would like to wish for the conference to have good works. And thank you again, Professor Bardis, for giving me the opportunity to be part of this conference.
Thank you very much, Professor Kakaroudas. You and of course IEEE all the time, every time support our activities, and this is very special for students also. Your work is very nice, and we will also support as we can. Thank you very much. Thank you very much. Second, welcome. We would like to invite Professor Kaimakamis. He is the Dean of our Hellenic Military Academy, and as supporter and of course as organizer. Professor Kaimakamis, please.
Thank you very much, Nikos. Dear friends, dear colleagues, dear researchers, it is a pleasure for me to welcome you to the annual DESSERT conference. This conference will provide, I'm sure that will provide an opportunity for all of you to present and update results related to techniques and tools in various and specific interesting fields, such as security and safety assessments, artificial intelligence. And of course, I want to express my deepest and many thanks to our member of the organizing committee, especially Nikos Bardis. I know his efforts the past 3 months. Nikos, thank you very much for all of your efforts. I hope that you will benefit from this conference and the sessions that will take place in the next 2 days. At last, I wish to all to you a successful and fruitful event. Thank you very much.
Thank you, Professor Kaimakamis. Of course, our university helps very much here, this organization. And I think next time also Ukraine will invite us in Ukraine. Huh? Thank you very much, Professor Kaimakamis. Also with us in Greece is rector of National Technical University of Lutsk, Irina Vakhovich. Please, thank you, Irina. Hello, Irina. Irina, open your microphone.
Доброго дня учасникам конференції. Я буду говорити українською мовою, і в мене буде помічник, пан Олег Іляшенко з перекладом.
I would like to hardly say welcome to all participants of the conference.
Шановні учасники конференції, від імені всього українського народу я вітаю вас з тим, що сьогодні кожен свідомий українець має, мабуть, розпочинати всі заходи з слів подяки. Подяки нашому українському народу за те, що ви робите і як ви нас підтримуєте в такий нелегкий час, який сьогодні переживає наша країна.
I would like to address the following words to all the participants on the conference. First of all, we as a Ukrainians, we need to be thankful, and we are very thankful for all Ukrainians who are now struggling within the war, with these tough times for us, for Ukraine. So thank you everyone who are involved in this.
Не дивлячись на те, що в нас сьогодні іде агресивна війна Росії проти українського народу, наша освіта і наука проявляє незламність.
Despite of the fact that nowadays during this time there is the very big aggression of Russia against Ukraine, our science and our industry is showing that we can stay strong and face this bad situation.
Адже освіта та наука – це є символи майбутнього і це є символи незламності нашої країни. Освіта – це є додатковий фронт нашої країни.
Because in science and education is the symbol of the future of Ukraine, and these are symbols of sustainable development.
Дякую грецькій стороні за всебічну підтримку і за можливість проведення конференції.
I'm thankful for our Greek colleagues about the possibility of hosting the conference and about the possibility of organizing the conference jointly.
Бажаю всім учасникам плідної роботи, цікавих дискусій, нових ідей, ну і, звичайно, перемоги. Перемоги, спільної перемоги цивілізованого світу над нецивілізованим.
And I wish all the participants of the conference fruitful discussions, interesting ideas and new projects. And what is more important, I wish all the civilized world, unite world, our joint victory against uncivilized world. Thank you.
Thank you. Дякую вам.
Thank you, Professor Machovitz. Thank you very much. Keep in mind that all the time we are near you, near your country, near your people. So, of course, we will support with all our power on that. Thank you very much that you are here, and it's very useful that you are in Greece, and also we will have time to visit our university and to make all the agreements that we can in the future we can work on that. Thank you very much. Near me is our also Professor Harchenko. Vyacheslav Harchenko is organizer also from his university, and also he's a general chairman of this co-chairman in this session and this conference. Please. Yes. Mm-hmm.
Good day, dear colleagues, dear friends, dear participants of 12th IEEE Conference on Dependable System Services and Technology. It's my pleasure to thank our host, our Greek colleagues, personally Professor Nikos Bardis, all people who work in the military academy who participate in the organization of this conference. Our conference started a lot of years ago, and now we have a possibility to continue our joint work at the beautiful country, it's Greece. Sorry, we cannot participate all here. I have such possibility, and it's my pleasure to thanks once more our hosts. As said, Rector of Lutsk National Technical University, Professor Irina Vachovich, we have a very difficult time in Ukraine. The war is Russia, but we, as people who work in university, in science and education, should go ahead and develop our research project, our education activities, and so on. I wish all participants of conference good, interesting, and good results of good discussion during our conference. I would like say a few words about history of our conference. Our first DESSERT conference was held in Poltava, the center of Ukraine, 16 years ago. It's a very beautiful city. I hope all our Greek colleagues, our Greek friends will have possibility to come to Ukraine and in Poltava as well. Next 5 conferences we held in Kirovograd now is Kropivnitsky city. On the base, research and production company Radi is a leader manufacturer, developer, and supplier computer systems for nuclear power plants. And our department a lot of time cooperate with this company. And the history of our DESSERT conference is connected with this city, this company. Next few DESSERT conference we held in Sevastopol on the base banking institute. It was very beautiful place, nice institute. Sorry, now this part of Ukraine occupied by Russia. Next, our meetings, our conference were held in other city of Ukraine. First of all, in capital of the Ukraine, in Kiev, on the base Taras Shevchenko National University, Banking University, and besides we held our conference in Chernivtsi, in Kharkiv as well. In 2019, our conference was invited by Leeds Beckett University, and Professor Gorbenko, as our colleague, our friend, organized with colleagues from this university conference in United Kingdom. Our conference in 2020 was online, caused by COVID-19, as you understand, and we successfully held this conference as well. Formally, it was Kiev and Kharkiv online conference. You see our cities. Sorry, now the part of building in Kharkiv and Kiev were destroyed during this month of the war. And now we have possibility to held our conference together with our Greek colleagues on the base of military academy, and it's my pleasure to invite you for interesting work. Since our colleagues from IEEE Greece section, because they support helped us with receiving of IEEE status, and thank you so much for these activities. A few words about statistics of our conference. 66 papers have been accepted by 203 authors, and will be published in the DESSERT proceeding to be included in the IEEE Explorer library and indexed by Scopus. We have participants which represent 70 countries from all continents. Sorry, we have not participant from Australia, but I hope next our meeting will be with Australian colleagues as well. The main topics, the main theme of this conference is dependable and trustworthy artificial intelligence, Internet of Everything, big data analytics for safe and secure work. Now it is very important for our country, for all European country, and not only. We have 5 plenary sessions, 10 topical sessions, 2 special sessions related to aerospace, radioelectronics and computer system services and technology, dependable system, and our special session is dedicated to big data, big geospatial data in context of security, Ukrainian and European Union as well. It's our pleasure as organizers of this conference to thank our keynote speakers, Professor Xiaodong Liu, Professor Tatiana Zebi from Edinburgh University and Technical University Vienna, correspondingly, Dr. Peter Popov, City University of London, United Kingdom. Peter, a lot of time supported our conference. Thank you, especially Peter. Professor Natalia Kusul from National Technical University of Ukraine, Sikorsky, Kiev Polytechnical Institute. Co-general chair of our conference, Nikos Bardis, studied in this university and defended his PhD dissertation. Hence, there is a strong, long-time connection with this first technical university of Ukraine. Our next keynote speakers is Professor Andrzej Rusiński from National Hampshire University, United States, and Dr. Tadeusz Paul Kochansky. He represents Sensor Signal System company from United States as well. Andrzej and Ted are native Polish people, and we a lot of time communicated with them and go ahead on our conference, and not only. It's my pleasure to present our keynote speakers, Professor Sokratis Kasikas from Norwegian University of Science and Technology, and Professor Peter Stavroulakis at Technical University of Crete. And our industrial speakers, Dr. Mario Fusani from Institute of Information and System Technology, Pisa, Italy, and Tal Katran is accelerator guru from Israel. And two our colleagues from Infinium Technology company, the German-Ukrainian company, Dr. Alexander Karpin and Dr. Orest Akimishin. Thank you very much for all our keynote speakers for future very interesting presentation. Very short about framework of our and schedule of our conference. You received this information before. Sorry for some delays with more detailed program. Hope we will go ahead according with our schedule. We have all communication and presentation timing for our keynote speaker. We have about 40 minutes, including question and answer, and the session talks about 15 minutes plus 5 minutes for question and answer. Many thanks all organizers of this conference. First of all, hosts of IEEE DESSERT conference, Hellenic Military Academy, University of Thessaly, our Greek colleagues, and of course, one more thanks, IEEE Greece section, and our colleagues from United Kingdom, Italy, and Ukraine. We thank all participants of committees, including program committee, first of all, and our partner and sponsors, which present industry and different organizations such as Association of Industrial Automation of Ukraine and Ukrainian Scientific and Educational IT Society. And we thank all participants of this conference for your activities to support our conference. Thank you very much. And usually we, as last slide of welcome presentation with Ukrainian red, the Karavai, and I think this photo is very, very good added by traditional, the perfect Greek olivki. I don't know.
Olives.
Olives. In Ukraine, knows and like, and not only Ukraine, all countries know about this beautiful product. Thank you very much, and wish you successful DESSERT conference. Thank you.
Thank you, Professor Hancheko, for your good words about all this DESSERT conference all of years. And I think that now we have to start with our plenary keynote speakers. And we're very happy to invite the first our keynote speaker, Tanya Zebi. Please, Tanya.
Hello.
Thank you.
Yeah. Thank you very much for the introduction, and thanks for inviting me to this quite exciting event. It's good to see that science continues, and despite the hard conditions we see nowadays. The topics, I think, are very important nowadays and also become more important in the future. So I will try to share now my presentation. Let me see. Okay, can you see the presentation?
Yes, yes,
Okay, very good. I cannot see you, so if something goes wrong, you need to, or if you have some questions, you need to raise your voice, but I guess it's okay. Okay, so welcome to my talk. My talk is about malware communication in critical infrastructures, and my research field is the detection of malware communication in the network traffic that we see in critical infrastructures. I will start with mentioning a few general challenges that we face if we want to detect such malware communication, and then we'll go in depth into particular problems we have because malware communication can hide in using different hiding techniques. As you all know, we have many different critical infrastructures. That means infrastructures which are very important for the society in a sense that if they are destroyed or if they are not functioning well, that then this becomes a problem for the society. So we have critical infrastructures in the different domains like health, transport, food supply, water, media, and so on, the government, of course. And in my talk, I will especially look into the energy networks and the combination of the energy network with the communication network. Of course, the communication network is also a very important critical infrastructure, and that's also my field of research, and I see it somehow in the center of those critical infrastructures because it's important to support the other infrastructures. Especially with the energy network, with the power grid, we more and more see smart grid developments where we have sensors in the electricity grid in order to see stability issues and so on. And we have a strong relation between the energy network and the communication networks, because if we don't have power, then communication also is difficult. But also if we don't have communication, or if somebody tampers with the communication, it can harm the energy networks. Why do we need the smart grid? So why do we have communication, or why do we need communication in the smart grid? Well, first of all, for the grid operation, so we see more and more the integration of renewable energy sources, so which are often quite volatile. That means you cannot predict very well when, or can just predict to a certain extent when you have energy. And also a decentralization. That means you have a photovoltaic maybe in your home, and this gives some problems with the network. So we need to monitor the network, the grid network, the electricity network, in order to see if there are any stability issues. The second thing we want to do is demand-side management. So we want to encourage people for using the energy when it is there and when it is cheap. So we want to use flexible tariffs, or want to control home appliances based on the supply we have. One field which is coming more and more is e-mobility. That means electric cars. We see more and more electric cars. And then you can imagine that demand-side management is very important because if many people at the same time come at home and charge their electric vehicles, then this gives some peaks in the demand side. The problem that we have with if we put communication networks in place there is that, of course, we can get cyber attacks. So you can think of attackers who manipulate sensor values or modulate demand patterns in order to pretend that something is there which is not. So you can invoke wrong control decisions by the control centers, or you can even lead to instability, frequency instability, for instance, or if you compromise devices, which often attackers are targeting, then you can have blackouts. And we have seen in the past several events where this happened because of cyber attacks, that blackouts happened. So therefore, we have very high security standards if we want to kind of deploy the communication in the smart grid. We use security protocols more and more, and also classical internet protocols, IP, TCP, in those environments, and the according security protocols. And also we make use of digital signatures. This is a very good development, so that we see more and more security measurements. But as we will see later in the talk, also those security measurements can be misused by attackers in order to invoke some malware communication. I give you two examples for communication in the electricity grid. Of course, you all know smart meters, which are communicating to some meter data management, but we also have more fine-grained measurements in the electricity grid, like phasor measurement units. Phasor measurement units, or so-called synchrophasor measurements, are very fine-grained measurements about the sinusoidal signals in the electricity grid. And we want to check if there's a phase shift of those signals if we measure them at different locations. And if there is some large phase shift, this can be a hint that there is something wrong in the network and that we need to do some countermeasures in order, for instance, to prevent a blackout. So those measurements are very fine-grained, a lot of measurements there, and they need to transmit it to some control center, and therefore often over a wide area network. So here you have typical structures like that you have at a substation, that you have multiple phasor measurement units, which report then to a phasor data concentrator, which concentrates the information, aggregates it, and then maybe there will be a super PDC further integrating data or aggregating data, and then it's transmitted to a wide area network. And then a control center, based on the situation that it sees from those phasor measurement, can invoke some control decisions in order maybe to prevent some blackout. You can imagine what can happen if you have here somebody is possible of tampering with the data or can kind of control one of those devices. Or here on the way from the device, from the measurement to the controller, can somehow tamper with the data, then we might invoke wrong control decisions. Another example is e-mobility, which we see more and more. And we have this is a picture from a project which we worked on those, on security in those architectures. And we asked the project partners to kind of sketch how the architecture looks like and what protocols are involved. And this was kind of the result that we saw. So you see here different, like the charging stations for the electric vehicles, and then they report to a charge point operator. They need to authorize themselves that they're allowed to charge, maybe with a payment card. You also could have roaming scenarios here, and you see that there are a lot of different stakeholders involved and a lot of different protocols that you have here. You can imagine that it's very hard to ensure security in such a complex environment. So if you look into the attack surface that we have, for instance, for the smart grid, and we see here like an attack tree, where we can say maybe the ultimate goal of an attacker would be to provoke a blackout. Now, if the attacker has only physical possibilities, of course, the attacker can cut transmission lines or physically manipulate some breakers and so on. For this, he needs to gain some physical access to those devices. However, if we have the smart grid connected with internet technology, we have much more possibilities to attack the electricity grid. We can kind of compromise some devices. We can use devices on the way from the measurement to the control center, or kind of changing the control commands, for instance. So here, the attack surface is much larger. So now the question is, why do we do cyber attacks, or why are cyber attacks so attractive for attackers? Of course, we see a lot of conventional attacks on critical infrastructures, of course. But if there are cyber attacks, you can do those remote. So you can attack the physical infrastructure via the cyberspace. You can control it from remote, and that means you do not need to send somebody there. This also, you have a lack of attribution. That means you can conceal who you are and what is the origin of the attack, or even pretend that you are somebody else in order to invoke some conflict, for instance. Another thing, what we see in such critical infrastructures very often is that we have a quite homogeneous infrastructure. That means you have many different sensors of the same type, for instance, like those phasor measurement units, smart meters, or electric charging stations, for instance. And here, if you find one vulnerability in such devices, then you can compromise many of such devices. We did some time ago some simulation of different architectures that you can use, and if you have here the devices interconnected in different networks, and you have a worm spreading there, you can see that the spreading of the worm in this simulation gets quite fast. An additional thing is that you have limited resources available, so sensors should be cheap, for instance. And then it's very hard to deploy modern cryptography in this. If you have memory and computing power, not so many resources for this, then it's hard to deploy security measures. And a third thing is that you have very old devices in the field. Usually they are targeted for like remaining 10 years in the field. And then you can imagine what happens if an attacker with a 10 years advantage can kind of do what kind of harm such an attacker can do. So cyber attacks, this is very tempting for attackers and for attackers which have a lot of resources like nation states or terrorists. Another thing which we need to keep in mind if we have cyber physical systems, that we often use state estimation, for instance, using Kalman filters and so on, for predicting what's going on in the network and if the values are kind of okay. And you can use, for instance, the residuals from the Kalman filter prediction for detecting if there's some bad data and so on. And if this is used, you can use this, of course, for detecting some anomalies, but it's also easy for an attacker kind of to trick the system. So here we try to increase the voltage values. We increase the measurement values, not the voltage itself. So we just pretended that the voltage is increasing. And if we do this slowly and with some noise over this, then we will not see this in the detection. We just see here those large outliers which were not caused by us. So the question is, like, it's attractive for attackers, and many times we see so-called advanced persistent threats where attackers remain a long time in the network in order to prepare and to do some more research on what's going on in the network in order to prepare attacks, and then launch a controlled or timed attack. So the question is, maybe attackers are already in the network and spread their malware there. So we can, of course, prevent attacks, which is very important, that we have updated software, that we use security protocols and so on. But nevertheless, we always can have zero-day vulnerabilities because software can have errors, and also humans can make errors in choosing bad passwords, for instance, and so on. So if attackers are active in the network for quite some time, we can try to find out if there's some activity going on. They try, of course, to remain undetected, but malware also needs communication to spread, for instance, and therefore we have maybe a chance to detect this. And this is my main field of research, the detection of anomalies in this network traffic. So if we look into the malware lifecycle, we see that there are different phases in which malware needs to communicate. For instance, the reconnaissance, checking out for new victims in the network, infecting other machines there, spreading the malware in the network. Also data exfiltration, so exfiltrating some important information from the network, or also establishing botnets or command and control infrastructures for steering further attacks. For all this, the malware needs to communicate. So if we have the security measures, of course, I said, like, prevention is very important, secure protocols, awareness also for the humans, checking the configuration, doing firewalling and so on, and having all the software up to date. But also we need the detection part, because for the prevention, we only can prevent attacks which are known or which we can easily predict somehow. And with the detection, we also can capture novel attacks in a way that we can see if something deviates from the normal behavior in the network, and this could be then attack or attack preparation activities. Of course, if we found an attack, if an attack went on, we should do some forensics in kind of seeing what happened and then taking the attack patterns that we detected and taking them into account for the prevention then. When we look at malware communication, we see that the malware, of course, evolves. So attackers also learn a lot. And here you see part of a list that we did on different botnets that we have seen over the many years. And you can see that, like in the past, they often used the IRC protocol, but nowadays they use very common protocols like HTTP or HTTPS, which are usually often okay for the firewall. So the firewall lets this information through. And you see also that more and more malware is using encryption, like here the transport layer, security protocol, and so on. So with this, it becomes very hard to distinguish the normal encrypted traffic, which is of course very good, especially in critical infrastructures. We use encryption and authentication more and more. However, then to distinguish if a flow is malware, if the communication is originated by malware, or if it's from a legitimate, or if it's some legitimate communication, is very difficult. So the attackers try to avoid the detection and try to look as normal as possible, like the existing communication patterns. So when we want to detect this malware communication, we face a lot of challenges here. So the normal detection part that we do, we have here the network traffic. We observe the network traffic in the network. And then we can already filter something, saying we are just interested in particular data packets there. And then can also aggregate this information into flow data. Let's say we aggregate all packets from one source to one destination because it's the most interesting for us, like for instance, from those sensors in the grid to the control center. And then comes a very important step, that is generating a feature vector. That it means, what do we give the detection algorithm as input? So here we extract information like the number of packets or packet sizes, or also where they are located and so on, or some statistics about those flows that we see there. And then we have the detection algorithm, which can be different kinds of detection, just looking for particular signatures, simple statistics, for instance, but also more machine learning is used in this domain. And then we get the decision, which is no attack or attack, but also could be a level that you say 60% attack, and then a human would need to look again into this data. We see, as I said, more machine learning based detection. Here, this shows a statistic about like papers that we checked in the past, which did different machine learning technologies for network traffic analysis. And you can see that many of those use very simple machine learning methods like decision trees or random forest. And this is because those techniques are more or less explainable. So you can explain the decision that the machine learning did. And therefore, first of all, you can derive some rules from this, but also you can make sure that nobody kind of tampers with the machine learning. If you have a classical machine learning like neural networks where you don't know how the decision was formed, then then there might be a problem that an attacker can kind of trick the system. However, we see here that neural networks are also used more and more just because they are so successful in other domains, and therefore we use it also for the traffic analysis. One very important thing is the feature selection. So what features do you give the decision process as input? I always make the example here with a needle in the haystack, because this is often the situation that we face looking for the malware communication in all the communication in the electricity grid. And if you have here, if you visualize here the properties of the elements in the haystack, so the hay and the needle, and you choose as features the length of the element and the diameter of the element, you can see that the needle blends in very well. You cannot distinguish it very well from the other elements in the haystack. However, if you use the features more wisely, so you say here, you check the weight of the elements, and if they are magnetic, for instance, then you can see that the needle sticks out, and that is very simple. You can make a very, very simple decision algorithm, a linear classifier here, in order to distinguish those two classes, the needle and the hay. So the feature selection is an important step in this. We looked at one data set which multiple researchers in different papers investigated regarding how good those features are to detect attacks. So this is the same data set, the same 41 features which were used in all those papers. And the authors kind of said in their paper how important they think to those features are to detect attacks. And they are the same attacks, the same data set. And you can see that here the different papers heavily disagree about this. So here you have, like, for instance, this in this paper, the feature 14 is considered as having a very strong contribution to the detection of the attack, whether in this paper they say it has no contribution in detecting the attack. So it's very important, like, that here you do this properly, the selection of the features, in order to then later feed your detection algorithm. Another challenge that we face is we often have more and more encrypted traffic, network traffic. This is very good. So as I said, in the critical infrastructures, we need this traffic needs to be encrypted and authenticated, that we can make sure that nobody tampered with the data, or that nobody finds out about, for instance, if you have the phaser measurement units, if it's not encrypted, you might find out about, like, the device, where it's located and what kind of firmware it has, and so on. So therefore, it's a good development that we see more and more encrypted and authenticated traffic. However, with encryption, it becomes harder to distinguish. So the malware communication from the legitimate communication, and we do not have all the features available that we have. For instance, if you want to look into the transport port, which is part of the TCP header in this IP packet, it is available if you use transport layer security encryption, but it's not available if you use IPsec encryption. So it depends on the security protocol you are using, what kind of features you have available. We looked into detection methods, just using features which are available in encrypted traffic. And here we made an approach where we use different granularities. We called it a multi-key approach, where we use different granularities of the flows. So let's say I want to check all the communication that comes from one computer, from one host, from one sensor. Or in addition, we look into the communication from this sensor to other machines, and so on. And with this, we could achieve quite good results, although we only looked into features which are available even with encryption, like the packet sizes, the packet timing, and things like this. And then also what we often want to do is to have online detection. So we are dealing with streaming data. And with streaming data, situations can happen that you're online, you have your detection machinery going on, and here you need a sliding window in order to see what you have seen before, and then to decide if then the data point is an anomaly or is normal. And if you have, for instance, a sliding window only quite short, and then you get a new data point, you would think that this was an anomaly because you just see this cluster here. Whereas if you would have a larger sliding window here, you would see that here is already a cluster in the same range at this data point. And then you would think this is rather an inlier, not an outlier. Yeah? So this is kind of a difficulty, because if you do the sliding window too large, then you need more memory. And some solution might be to, or is here to define such observer points in the clustering. And then with this to make a lightweight model of what's going on in the data. And with this you can then achieve have here this detecting as an inlier, that you know, okay, this I have seen before, and increase the detection technique. So here you can see this was one, the SDO stream, this was one method for the outlier detection, where we actually used this model, and which performed quite good compared to other methodologies that we have. And last but not least, if we look for detection of attacks, of course, we have an adversarial environment. So we have an adversary who wants to trick our system. And if we use machine learning, for instance, then the adversary can try to kind of modify the attack in a way that it evades detection. So here we see the detection rates if we have unmodified feature vectors, and if the attacker do some manipulation of the feature vectors, it can reduce the detection rate immense. So here you can really reduce the possibility. These are two different data sets, and here different attacks in those data sets. So you can reduce the possibility to detect the attacks by manipulating those features here. We defined some kind of an adversarial robustness score in order to kind of see how robust certain systems are regarding this manipulation. So now I want to dig into a very big challenge that we have, and this is the hiding of the communication that attackers are doing. So here we see that there's well, you all might know steganography, and that means we conceal the existence of the message. So here, for instance, you have a picture, and in this picture is hidden a different picture. You might all have seen this. You also can see this in the network. Like, for instance, we have here it's called the network steganography, and where you can say here instead of putting the information in the packets, we put the information between the packets. So we can say here, if packets timing is long, then it means a 1, and if the timing between the packets is 0, then this means a 0. If the timing between the packets is short, this means a 0. And this is like our technologies that attackers can use in order to convey some information in this way. An example is a SolarWinds attack, which you have heard of maybe, which was an attack of a monitoring tool, and where many US government organizations and ministries have been affected, and they use the covert channel in the DNS traffic. So those channels are very hard to detect. One question to the organizers, how am I with time? So do I still have some time?
Yes, we have some more time.
Some more time. Okay, just stop me if I'm over the time. Okay, so those are very hard to detect. So we have different kinds of hiding information. So the one is the covert channels. That means you hide the information, for instance, in packet headers. So for instance, the IP header where you have time to live or IP identification, or in the TCP header in initial sequence numbers and so on. So you can hide their information such that only a covert receiver will kind of get this information. You can also use packet size variation, saying large packets mean this, small packets mean this, or also timing variation. And with this, you can remain undetected you can hide in the normal traffic. And of course, if you have more and more IP and TCP protocols or even in TLS or IPsec, you can find those fields. You have this in the critical infrastructures, but also with a connection to the whole internet. So this is quite a broad infrastructure that you have to communicate for your malware. An even more concerning method is subliminal channels. You all know digital signatures, and they are an important basis for many security protocols. So they help you to authenticate the data origin. So only a machine who knows a particular private key, a secret key, can make a correct digital signature. And with this, if you have a digital signature on your data, if you think like the sensor data, you give it a stamp, a digital signature, that you know this came from this particular measurement device, from this facial measurement unit, from the e-charging station, and so on, in order to ensure that nobody is kind of tampering with the data. So they are broadly used. They are a very important element in security protocols, and it's very good that they are broadly used. However, you can also use those digital signatures in order to hide communication in the signatures. The reason why you can use it is that signatures often use random numbers or also initialization vectors or nonces and so on, where you can put then information in it in a way that anyone who is looking at the signature would not notice any difference. So, but that the covert or that the subliminal receiver can extract this hidden information from the signature. There are many signatures which are affected from this, like the elliptic curve, DSA, many high-speed signatures, or also post-quantum signatures, which have this property in it. And of course, in the security protocols, IPsec, TLS, we use those signatures. So here, in this case, an attacker could misuse even our security measures that we do for using this for malware communication. I give you one simple example for how you can hide information in the signature. Here's the El-Gamal signature, which is used in the digital signature algorithm. And here you have the two communication partners, Alice and Bob. Alice wants to generate a digital signature. She selects a prime number and a prime number P, a generator G, and then generates a random number small a, which is her private key, which she should not reveal to somebody usually. Then she calculates a capital A in a way G to the power of small a modulo P. So this is a good solution here, because here it's very hard to find the small a, the private key, if you have just the capital A, because this is would be a discrete logarithm, and this is, you cannot find the small a there. So therefore here, Alice just sent those parameters to Bob. These are the parameters that Bob needs then in order to verify if the signature is correct. And then she generates the signature by choosing a random number, K, then computes R and S in this way, so that those R and S here then become the signature. So then she can send the message, that could be the sensor data, for instance, and put a digital signature there, so that Bob knows only somebody who knows this private key can have originated this message. And then Bob can validate, verify if this signature is correct by just doing this calculation here. So now here, if you want to hide some subliminal information in the signature, you can just, instead of choosing a random K, you can put the subliminal information into this K and then do the whole procedure as usual, and then the signature will look normal to Bob here. One thing that you need to make sure in advance, you need to share your private key, what you usually should never do. But in this case, you have some collaborator, some subliminal receiver with whom you later want to use this subliminal communication, and you need to share this private key with the subliminal receiver that he can recover the message later. And then put different messages here in this K, generate a signature, then generate the next signature, and so on and so forth. And the verification, as I said, is not affected. So for Bob, it would look like a normal signature, or anybody else on the path who can verify the signature, it would look normal. But a subliminal receiver who knows the small a can be anywhere on the path of this communication, and then can recover the subliminal message with this information he has. You can use this, for instance, for the PMU measurements. So for the phasor measurements, if you would assign all the measurements here, then you can have the subliminal receiver on the path, and the receiver here, the normal receiver, would not recognize that you are exfiltrating some information from devices in the security domain. Also for the network time protocol, so time is also, clock synchronization is also important in critical infrastructures, of course. You can use this in order to exfiltrate information there. And also in the TLS handshake, for the establishment of the secure connection, you usually use signatures just for the mutual authentication. So then you would have just a possibility per handshake, per connection establishment, to put some information in there. In this project, which I mentioned on the malware communication in critical infrastructure, we also checked other methods to kind of convey some information. And there's one very often used authenticated encryption method. You might heard of the AES encryption, and there's a AES Galois counter mode authenticated encryption, so encryption with authentication, which is used quite often in critical infrastructures or also in smart metering. And in this, you here also have the possibility to hide some information in this authentication tag. With this, you can kind of exfiltrate information from a secure environment to a less secure environment. And also, if you think like blockchains have been a big hype some time ago, where say blockchains are used for many different things, and You can also have digital signatures in the transaction blocks here, where you can then hide information here, for instance, in the elliptic curve digital signature, which is used in the Bitcoin blockchain. You can hide messages in the signatures, and this is public, so the blockchain is public for everybody. So then subliminal receivers who are maybe a botnet, for instance, you can use this in order to control a botnet when the bots then just recover this information from the signatures. For everybody else, it would look like a normal transaction. For this, we did even a proof of concept. So we injected some subliminal message in the public Bitcoin blockchain. So if you want, you can actually extract this information from the blockchain. It's still there. And we did some hiding of this message in the signatures, in the elliptic curve digital signature. And then botnets could extract this information in order to use it for steering a botnet. And you wouldn't see any unusual transaction pattern. So it's very hard to detect. Okay, with this, I come to the conclusion of my talk. We've seen it's very important that critical infrastructures more need communication for the operation and many future demands, like, for instance, the integration of renewable energy, but this enables the possibilities for doing cyber attacks. However, also the malware, especially very sophisticated malware, needs communication in order to establish command and control structures for steering a botnet, for exfiltrating data, or for spreading in the network. And therefore, we have a chance to detect this communication and to see if an attacker is already took hold of our network or is already spreading in the network or already is getting some information from the network, which we don't want, of course. However, the malware developers use more and more sophisticated methods. So, for instance, hidden malware communication, which is very, very difficult to detect, like the covert channels, hiding information in the packet headers, or subliminal channels hiding information, for instance, in digital signatures. So with this, they would even use our security measures, like the security protocols or the signatures, against us. And then here the detection is very hard. So with this, I thank you for your attention. And now I'm ready to answer some questions if we have time, I guess.
Thank you, professors. Thank you, very nice, very interesting your lecture about the malware's communication in critical infrastructure. I think it's what we need now, today, to keep safe our infrastructures. Please, do you have any questions, please?
Can I ask?
Of course, please.
Professor Tanya, thank you very much for your interesting and very useful presentation. My question may be related to your first part of your presentation. I mean, you talked about combined attacks on physical and cyber assets. Problem is in complexity of defense from such type of combined attacks, because in this case, in point of view theory of a complex system, we need find balance between attackers and defenders. Hence, complexity of defense increases more and more. What is your opinion on how we can methodologically decide this problem? Mm-hmm. Because I understand that my question is very general, but I think it's a very, very important question.
It's a very important question. Yes, I absolutely agree. And the problem is that the systems get more complex, so that we have more and more, if you have seen like many different protocols in place, and then many different devices are interconnected. And often, well, it's good to have more simpler systems in a way that we, for instance, agree on certain protocols. So standardization is very important. And we have seen, especially in the domain of the energy networks, that when the smart grid development started, that there many different protocols were used, and also the developers of the electricity grid, they were not so skilled in the information technology. And actually, I was attending a call like 10 years ago with the IETF, this is the Standardization Organization for the Internet Technology, and with NIST, where they kind of talked about like how can we ensure more protect more the smart grid, for instance. And it was even very hard, like the different standardization organizations, they spoke a different language, I would say. So a network for the electrical engineering part is the grid network. For the communication network people, it's a communication network. But now we see a good development in a way that we use the internet protocol technology, IP, TCP, where we have a lot of knowledge what's going on, and where we have a lot of security measures which have been proven in the past. And if we kind of simplify the systems in this way, that we agree on common protocols, then this would help already with the complexity, I would say.
Thank you very much for your answer and for your presentation on more. Thank you.
Can I ask one more question?
Yes, please. Yes, please.
Thank you very much for your presentation. It's Alexander Lubimov from National Aerospace University. I'm representing both academia and and industry. You might heard about apparently zero-day exploits, and in my opinion, kind of filtering the traffic and trying to figure out what goes wrong is really good thing. But when I look into the fraction of root causes of systems being non-protected, I can see more and more, I would say, intervention of security gap problem using open source software, which everybody apparently wants to use today. So how do you see this trend, and what is your recommendation how to attack this problem especially for the industrial systems?
So you mean like, should we use open source systems, for instance, where everybody knows about the software?
Well, apparently we have, because we have to, because that's what industry demands. My question is, how would you recommend to undergo specific assessments, or what is your take on this problem?
Well, first of all, like using open technology is the key, I would say, because you have seen like that if you use some protocols or technology which nobody is aware of, then of course you might say people don't know the specification and therefore cannot attack it so easily. But on the other hand, if you really want to attack it, then you can find 0 days, and then you can find probably more 0-day vulnerabilities than in software which is open. So definitely it's a good development that we have open software, and that we have all the standards open, and that people can have a look into this, because the more people look into this, the better. We have seen even with the open SSL bugs, that even software which is open source, which has been around for more than 10 years, that even there you can find vulnerabilities. So this is a good trend. You have to kind of work together with different, you have to bring together different parts. The network detection is just one part which you can do, where you can say if somebody is communicating, but of course you also have on the system where you need to see what kind of log files do I have, and combine this together. So this is maybe the thing how you can tackle this. And also, the 0-day exploit, you can sell them quite expensively on the internet, and then it's also for the industry maybe important that they, there's bounty hunts where you kind of give money to people who find vulnerabilities, and this is of course difficult to pay more than the bad guys would pay. So this would be also a possibility to kind of try to tackle this problem.
Thank you very much. Well, I got another one here. What I hear from the industry quite often is that, the communication modules that industry try to use as kind of, off-the-shelf products. When you need to communicate, IoT products, Wi-Fi, Zigbee, whatever else you can use, everyone wants to have, ready-to-use solution to be able to integrate, to, decrease time to market and stuff. And quite often what I hear from my clients is that how we guarantee that all those Chinese authentic products, that they are not sharing the data with with unknown domains, so to say. We apparently want to communicate from point A to B, and we don't want this parasitic traffic to be generated to somewhere we don't expect sended traffic to. How do you see this problem? Do you see the generally the problem of of industry not believing those vendors from China, or how it develops?
Well, I think it's very good that vendors should not they should not believe in well, you should be very careful with whom you cooperate, and well, especially like exfiltrating information that you don't want to be exfiltrated. I mean, you can of course monitor devices, but it's very important with whom you do your cooperation, I would say. And I think it's good that industry is aware of such things, because you never know if somebody kind of incorporated some backdoor somewhere in the software and then can harm all your systems, or even hardware. You can have hardware Trojans in the hardware design, which is very hard to detect if you have in the hardware already some malicious part, and that can become active, and then if you think of long or large installations like the electric charging station, or we have the discussion with Huawei in the 5G network. So you know that several countries kind of don't want Huawei technology in the 5G network, and maybe for a good reason. Yeah. So you never know. You need to trust. You need to trust your partners. And therefore, I think it's good that industry is absolutely aware of this. Of course, it might mean that the costs are higher. But if you think of the costs, if some vulnerability or some backdoor is in such of those systems, they will be much higher. So security costs something, but it's very important to invest in this, I think.
Thank you very much.
Thank you very much, Professor Sebi, for your participation, for your lecture. It's very, very important, all of these things. Thank you very much. So let's thank you very much.
Yeah, thank you all.
Let's invite our next plenary keynote speaker, Dong Lee from Edinburgh Napier University.
Yeah, good morning.
Good morning, Professor.
Yeah, I share my screen.
No? Can you share it?
Yes. Yeah, I think you got it now.
Excellent, very nice.
Okay, great. Yeah.
Thank you. We have 40 minutes, Professor. Thank you.
Okay, thanks. Yeah, no problem at all. Good morning, everyone. Today, I would like to talk about next generation Internet of Things and how to use it to build new smart systems, such as cyber-physical system. About myself, my name is Xiaodong, and I came from Edinburgh Napier University in Britain. And you can see my email, and welcome to contact me for possible research collaborations. Oh dear. In Edinburgh Napier, I'm leading a research group. Its name is Intelligence-Driven IoT and Smart Systems. Our current research focus, I show it in this slide. Basically, we are focusing on developing the so-called smart pervasive system, particularly the IoT-based smart systems. Of course, we use AI technology to drive this kind of system. Cyber-physical system is one, probably most important example of this kind of smart systems. When we say we are using AI technology, basically we mean, firstly, we are using deep learning, machine learning technology, which is very common now. And meanwhile, we are using so-called knowledge-based technology, such as knowledge engineering, knowledge base, inference, and we are trying to link the two parts together to make the AI working. The first step is to make the data understandable by the machines, by the computer. So we are working to develop semantic data models for the data in this kind of smart system and for the data analysis of in this kind of cyber-physical system. Cyber-physical system is an interdisciplinary research area. To make it successful, you not only need data, not only need AI, you need software engineering technology, how to design the architecture for this kind of system, how to accommodate the AI components, how to accommodate the data analytic components. So we are researching the latest software architecture for cyber-physical systems. Notably, microservice-oriented architecture is the first choice for us. The cyber-physical system, to support its running, usually people deploy it in the three-layered environment. That's the cloud, edge, and IoT devices. How to coordinate to make these three layers working seamlessly, cooperatively? So cloud, edge, IoT continuum is another research area we are interested in. The software, the whole system of a cyber-physical system keep evolving. So software evolution is another research focus from us. Overall, I would say our research aim is to develop the new approaches, models, and architectures to improve the engineering of these so-called emerging software-driven systems. And the new features for these new systems and the new functionality and the new structure, all these are our focus. So we may define the same we are doing as intelligence-driven system engineering or software engineering. The relationship between IoT, internet, and a smart system, we can describe it in such a diagram. IoT definitely is the core foundation for any smart system, including cyber-physical system. We need the IoT technology. Of course, IoT is based on future internet technology, but the concept and the technology for smart system is wider than IoT itself. Not only the sensors, not only the Wi-Fi network, not only how they communicate, we also need to include the system architecture, wider hardware, and wider system features. For the next generation IoT, the challenges we are facing, the first one is it indeed is a multiple disciplinary research area. To build the next generation IoT, we need the concepts and techniques not only from computing, not only from even engineering. We need techniques from so-called non-technical, or even people say the social disciplines, such as we need psychology, we need cognition science, we need human-machine interaction, the interaction design, because this part, they are going to handle how the system will interact with the human users, how to make the whole system human-centric and even further beyond. Technically, we need system architecture for the IoT, for the IoT-based system. We need so-called system intelligence. By system intelligence, we mean AI technology mainly. And this AI technology not only including the latest, most popular machine learning, deep learning technique, and it should include the more traditional knowledge engineering technology. The two parts should both be included and should work collaboratively. The communication is a key part, of course. So 5G, 6G technology, that's something we need to consider when building the next generation IoT. Of course, security and privacy is a very critical requirement for the IoT and for the next generation IoT. The desired features for the next generation IoT, they are quite challenging. Firstly, we would say the next generation IoT must be more human-centric. It must understand human need, human context autonomously, and must be able to make a response around these kind of human needs. So we say the whole system must be more human-centric. The whole system must be open. It must be an open system. Means everyone, every system in the world should be able to join, should be able to contribute to the domain, to the technologies in this domain, and to an existing system. The new generation IoT will support collaboration across the border technically, across the border of departments, and across the border of regions. It's a decentralized system, and it must be more inclusive, means inclusive for people, for society. It must be able to protect the privacy, and the whole system must be able to run autonomously, and meanwhile, it must be able to win the user trust. People talk about explainable AI. Yeah, that's one aspect of this trust words. Okay, so it must be autonomous, must be intelligent, and meanwhile, it must be trustworthy. To make these challenging features of next generation IoT happen, we need a lot of enabling technologies. And these technologies must be engaged seamlessly and integrally. What techniques will need? My observation is we will need the 5G, 6G network, that's for communication. And we will need AI technique, that's including machine learning, deep learning, and also include knowledge engineering, and include how to link the two parts together to make the intelligence, to make the machine learning explainable. The whole architecture, particularly the software architecture for the next generation IoT and IoT-based system, must be dynamically adaptive. Means it can be adapted at the runtime autonomously. That's an important feature people are desiring. Okay, and microservice could be a good solution. And we need a technique about cloud, edge, fog, and IoT itself, and their continuum. Yeah. Digital media and human-machine interaction, that's something we definitely need. We want to make the interaction more natural for human being. Okay, so technique and interaction design theory, that's a must. To make the IoT-based system more secure, one technique we can use, and one technique which is very matching with the features of IoT, I would say that's the blockchain technology, because blockchain is a distributed, blockchain can have numerous nodes. Okay, so it's a very ideal choice. To conclude, I would say next generation IoT will be software defined. Yeah, software will play a very critical and very wide role in the next generation IoT. And in the modern IoT, we will need the co-design of both hardware and software and the network. Why? Because the IoT of the next generation will be so complex and will have very high intelligence. So only if we can engage hardware, software, network seamlessly in a co-design manner, then the challenging features of the IoT will be able to be achieved. In the second part of my talk, I would like to talk about technology we developed as an example of the next generation IoT and as example of the effort to develop new types of cyber-physical system. The name of the technology is context-active resilience in cyber-physical system. Yeah, the project was sponsored by the Horizon 2020 Marie Curie scheme. Okay. What is cyber-physical system? I think all of us understand this very sharply now. Basically, you can understand a cyber-physical system as a modern, comprehensive control system. It has a feedback loop. So the real world inside it, we are going to deploy many smart sensors and many actuators. And the sensors will sense the signal, sense the state of the physical world. And this step is physical sensing. And with this physical sensing, the sensor signals will be sent to the computing world, cyberspace. Cyberspace, of course, you may have edge, you may have cloud, and you use AI, you use software engineering, basically to make the computing software running. And the decision and analysis will happen in the cyberspace, and the decision and actions will be sent to the real world as actuation information. And this kind of actuation information will drive the motor, the devices in the physical world. And then the physical world, its state, its structure will change. Cyber-physical systems have been applied to the society, to the economy, to our daily life so widely. So there are millions of examples. We got smart energy. Yeah, we got smart city, smart building, smart home, and we got smart traffic, smart transportation. We got smart manufacture, industry 4.0. Yeah, we got smart healthcare. So numerous examples. The cyber-physical system, they playing very critical role in the society, in the economy. So one paramount requirement for cyber-physical system is highly resilient. Yeah, the system must be fault tolerant. If any hardware go wrong and any software going wrong, or even further, the system is subject to some malicious attack from the hacker from anywhere, then the system should be able to recover from this kind of faults and attacks and should be able to maintain the acceptable level of operations as much as possible. This feature, we define it as resiliency. Although resiliency is so much desired for modern cyber-physical system, the current state of art is the resiliency technology mostly they are responsive or they are quite passive only. So they didn't, dynamically adapt the whole system in an active manner to support the resiliency in a more active mode. Inside a cyber-physical system, there will be many human users. There will also be many hardware components and software modules. Each of these can be considered as a key component in the cyber-physical system, and they will have the need, the profile, and their intention. All this, we can model them as so-called context. So we advocate a modern, the future cyber-physical system should be resilient in a context-active manner, and the resiliency should be context-active. In this project, the methodology we adopted is use case-driven agile spiral methodology. The use case will play a key role, and you can see in the methodology we have 2 cycles. In cycle 1, we have a use case work package. So we take a smart home as a use case, and from this smart home use case, we detect the requirement for the new cyber-physical system. And these requirements will be feedback into the technology work packages, that's work package 2 and 3, which will focus on developing approaches, patterns, and intelligence of the system. And this kind of technologies and models we developed will be deployed in the use case of the smart home. Okay, then we got the first prototype. Then we will be able to move to the second cycle. The initial version of the prototype of smart home will be evaluated by the user, and again, we get feedback and we get observations and requirements about how to improve this kind of smart home. And then based on this, we are going to expand and refine the approach, pattern, and intelligence in work package 2 and 3. And then the new models, new approach will be used to develop the second version of the prototype. We used the IoT lab. We give it the name Sensorium Lab So it has lots of sensors. It can be treated as a smart home environment or smart office environment. And it has the software for emotion detection, emotion analysis. So all this kind of, let's say, modern IoT technology. The whole project includes 5 work packages. Work package 1 is a standard project management. Work package 5 is also quite standard. That's dissemination and exploitation. The technical work package include work package 2, context active resilience mechanism, and work package 3, context active resilience patterns, and work package 4, the use case of the smart home. I won't go to the very deep technical details of this project, but I would like to present some key profile of this technology as an example of how the system is developed and how it works. For the context model, we used ontology technique, and the context model we got include 4 layers. As shown in this diagram, that's the yellow, orange, blue, and purple 4 parts. Each part is a layer. The most physical layer is showing as yellow. That's the sensor layer. So the sensor will detect the signals from the physical world. And then the physical sensor signal will be sent to the second layer and being converted into machine understandable data. That's the orange color, that layer. As example, in the sensor layer, we may detect GPS coordinates, which is a physical signal. And this, in the data layer, will be mapped to more meaningful semantics, such as we know the location means a dining room. We know the location meaning a sitting room or meaning a kitchen. The third upper layer is blue layer. That's the context layer. So we are going to analyze the data in the data layer and going to detect the context. Example of context could be we find out the user is a senior citizen and he is in the bathroom or he is in the kitchen. So that's the context and what they need. All these are context. The most top layer is showing in purple. That's the activity layer. Basically, it means we are not only going to know, the context, but also we are going to detect some activities about the hardware component, about the human user, such as we detected the senior citizen is in the sitting room watching television, want to calm down, from some quite emotional matters. The context active resilience framework, it works in 1, 2, 3, 4 parts. From the physical space, we got sensors, and it will detect the context, and it will get the signal, convert it to data, and get some very basic context here. And the context is saving in the context database, represented, and some basic reasoning happening in the physical part, physical space part. And then we are going to move to the activity mapping part. We use the deep learning technique, probability model to detect the activities. Okay, that's activity recognition. And we predicted the activity, in the next step. Okay, that's activity prediction. Based on the activity we detected and predicted, the system intelligently pick up so-called proactive adaptation patterns from the repository. And these proactive adaptation patterns will then be applied to the physical system, the environmental mapping part. And by applying these adaptation services, the interface of the cyber-physical system can be adapted to the user's need, and the function can be adapted, and the quality of features can be adapted. Okay, that's the technical part of this, say, car technology. Beyond the technical development itself, we actively entered public engagement. We actively engaged in the industry dissemination and exploitation. We contacted many institutions, public organizations, did the road show, did the industry showcase, and we contacted quite several companies, trying to commercialize the technology we developed. Okay, I think that's nearly 40 minutes now. So that's all I prepared to present to the conference. So I'm happy to take some questions. We still got a few minutes. Okay, thank you for your interest.
Thank you so much, Professor Xiaodong Liu. Your presentation was extremely interesting and motivated. Dear colleagues, we have time for your questions. Any questions? Okay, I have one, maybe more philosophical questions. In the beginning of your presentation, in your contents, you talked about continuum,
Yes.
edge, IoT, edge, and cloud. We know that there are fog and other levels of these continuums. What is your opinion? How much such levels will be in future? Now we have discrete hierarchy, yes, 3 or 4 levels. But step by step, we can go ahead, and the number of levels can be increased. And question is, what your opinion concerning future of this hierarchy in context of your presentation? I mean, security issues for such kind of infrastructure, IoT-based systems. Thank you.
The continuum is a very complex issue. We got focus, and we currently, let's say we got 3 layers in the continuum, and because the whole system will be deployed across these 3 layers, and all these are networked, so security privacy will indeed be a critical issue. So my view is blockchain is a very good choice for IoT-based applications. Yeah, particularly at the IoT layer, you got many sensors and other devices. So each of these may be considered as an agent and may be considered as a node in the blockchain. And then you design a protocol, such as for the digital identity identification. And so the whole blockchain, can run in a peer-to-peer structure. And to make it more efficient, again, we need to put much blockchain-related computing at the edge server, and even further, we put some at the cloud layer. But the higher we put something at the layer, then it will become less real-time real-timely responsive. So real-time response is another challenge. So when we deploy the services and also the blockchain security services across the 3 layers, then we need to consider the real-time response. So something, we may deploy it at the IoT layer, which can be very much real-time, but the computation power will be very limited at the IoT layer. And then there is in the middle, and then cloud layer that's usually give you quite long delay in the response, but it can be a background layer to do some background non-real-time work. That's the idea I got in my mind at this moment.
And thank you so much. As I understand, now we have metrics with hierarchy level and horizontal ones, and these metrics should be resilient. And any new vertical or horizontal entities should not increase risks of successful attacks. Hence, I think it's very interesting and very challengeable task. Thank you very much. Dear colleagues, who would like to ask Professor Xiaodong?
Yeah,
we see. And Professor Tatiana Shmileva.
Thank you. I am from National Aviation University, and I have a question about human factor. Influence of human factor in your system. And the first, resistance from operators error. And did you have statistical data about influence of human factor on your system? But for example, in aviation, 17% of human factor in all accidents in aviation. But about your system, level of diagnostic of error of human factor, influence of human factor on your system in job. Thank you.
Yeah, that's a very interesting question. The human factor in the system we considered, I would say perhaps that's 40%, something like that. Yep. And we focused on the air current, that part. Yep. So what they need and how they can be more socially inclusive, such as if the senior citizen feel lonely because of COVID isolation, and then how the system may suggest some services, may provide some activities to, make the user or the senior citizen feel more inclusive that's I would say that the human factors we considered in the system.
Thank you. Understood. Human factor, this is important in the different job, in different wagon, because this is a operator, this is a human, and it's life. But your system very important in job. But the first from human, the first from operators in job, this is important. Thank you.
Yes, definitely. Yeah, I think that's something we need to further enhance in our future research work. Yeah, so myself and including my group, we know some concepts of human-centric, but overall, we are not expert on that part. So we do need, to explore more in that part and perhaps, collaborate with some experts in that part. Yeah, in the future research.
No, yes, thank you. Interesting.
Yeah.
Thank you. Any other questions? I don't see. And in our chat, no. Dear Professor Xiaodong Liu, thank you very much one more for your very interesting presentation, for our discussion, and hope we will continue our cooperation not only in the CERT community, the CERT conference, and in maybe joint project and so on. Thank you very much. Thank you.
Definitely, and thank you.
Thank you. Dear colleagues, we have finished our first plenary session. Now we have short time for our virtual coffee break, and we will start 10 minutes later. We have two sessions, 1.1 and 2.1. I would like to say about our order with reference. We have two references for 1x sessions and 2.x sessions. All plenary sessions will be on the first reference. Hence, we will continue 10 minutes later. First session 1.1 will be here, and session 2.1 on the other reference, and the moderator of session 2.1 will be Dr. Oleg Ilyashenko. Session 1.1 we will continue here. Thank you very much for your attention, for your participation, for your discussion. Have you any questions? No. Thank you. See and hear 10 minutes later. Thank you.
Good morning again. Let's start our session. Okay, our first paper is measurement and optimization methods of energy computation of my control system with Internet of Things by Professor Osilinski, Alexander Osilinski. Okay, is any here from the first session for the presentations?
Dear Nikos, did you ask about participants from this section? Or only about Vasilkovsky?
Excuse me, Marina, can you repeat, please?
Did you ask us about all participants of these sections?
Yes, or the first one. The first one, is it here?
No, yeah, yes.
Okay, can you start? Thank you.
Okay. Good morning, dear colleagues. Now I will share my screen. Our presentation is about Markov model for availability assessment of PLC in industrial IoT, considering subsystems failures. Presenter is Marina Kolesnik from Department of Computer Systems, Networks and Cybersecurity of National Aerospace University HAI, Kharkiv, Ukraine. Axel Jansch, Institute of Information Technologies of Vienna University of Technology, TU Wien. And Irina Piskacheva from State Biotechnological University, Kharkiv, Ukraine. The new technologies. Sorry.
Please continue.
Yes. The new technologies such as industrial Internet of Things include different subsystems. You can see here the structure scheme of IoT system. This is not mine, but from famous source. And you can see here the place of PLC inside of complex system IoT, which consists of different sensors, light, motion, humidity, smoke, door environments, cameras, robotics, computer-controlled machines, IoT gateways, firewalls, and also PLCs. Not only the one, they can be in large number at the IoT system, and also special software for management SCADA systems and PLC systems, also special software like operation systems, like Linux. And the functioning of the IoT subsystems depends on dependability and availability of its subsystems. We can see examples of large modular PLCs from different producers, which can be connected to the IoT system like network device. And the structure of the large modular PLC, you can see in the figure 3 that it includes system components, service components, operation system, firewalls, different protocols, input-output components, global data space, and different communication protocols. And the goal of our research is to develop and to research evaluation Markov model of PLC availability. And for this, we used system analysis of structure of PLC system and used different states of and conditions of different subsystems. Assumptions for the developed model you can see at the slide, and availability is an important property of PLC dependability. We will choose mathematical apparatus of Markov modeling to assess availability of PLC. And novelty of this research is an access of PLC, like development of availability model for its structural subsystems, and assumptions like means of monitoring, diagnostic, verification, and validation are reliable and correct, determine the technical condition of the PLC. The process occurring in the system is a process without after effect. Each time in the future, the behavior of the system depends only on the state of the system at a given time and doesn't depend on how the system came to the state. The flow of PLC's hardware failures and also its subsystems is the simplest, random, and obeys the Python distribution law. Also, we can say about PLC software, we include software failures also in our model. And its flow is the simplest, also random, and obeys to the Poisson distribution law. And failures caused by errors in the PLC software and its subsystems also obeys Poisson distribution. Secondary error is corrected based on the result of validation and verification, and until the software failure is fixed. And we consider the number of primary defects in the software to be constant. Therefore, the failure flows of the PLC subsystems and the entire PLC have the Markov property. Our paper considers a PLC system that contains several subsystems. We used only main subsystems of large modular PLC. They don't change their position, they are static systems. So we describe PLC like static system. Communication protocols and software which are used for PLC functioning are also considered static subsystems. Therefore, to assess the availability of the PLC can be used the stationary coefficient of availability. We use such indicator and to understand and to simulate our model and to understand what different status and failures of different component subsystems of PLC will influence the availability coefficient of our PLC. Also, the graph of a Markov model is presented in figure on the next slide, and the states of a Markov model show states of PLC subsystems and transition rates from one state to another. We decided to assign failure rates like lambda and recovery rates after the failure like mu. Values of recovery transition rates were obtained with the time schedule tools for recovery maintenance after the failure. We had such project from Ministry of Transport, and with timing obtain different rates of recovery for such systems. Also, it was presented. Sorry, I have to escape and to go because I used some slides. The Markov model of PLC availability you can see at the figure on this slide. Each of these states can be, you can read in the 9th and 10th slides, and we used states of execution and synchronization manager, failure state of restart button of ECM, the second version, resolved version, random access memory, read-only memory, SD card, processor core the one, processor core the second, and failure state of 2 processor rates. Also, Profinet controller failure, Ethernet adapters failures, Xeoline F master, GDS module, OPC UA server, special software Profi Cloud, operational system Linux, and special software PC Works Engineer, also web server, internet user component, Wi-Fi adapter. And we can see that we can obtain the coefficient of availability using initial data of transition rates for the model simulation. We used average values of rates of failure according to statistical data, and also we can change this data using real statistical data from IoT system and from PLC which used in smart factory. And initial data of recovery rates for the model simulation we used with using these results of research in the real at real factory, at real for the real project. And results of the model simulation, you can see in figures 5 and 6. And we can see that analysis of graphical dependencies of availability coefficient shows that the value of availability coefficient is high, but not enough, because we have only 4 nines after 0. Requirement for PLC availability coefficient is 5 nines and 5. And no, this is complex system, and we used average statistical data. So with real statistical data, we can use more accuracy results. And also we can see a result of simulation of changing failure rate of random access memory, and we can see that the value of availability coefficient decrease in 100 times with increasing of this rate to 0.001. And also we can see such changing with failures with changing of processor core failure rate. As a result of the model simulation, we obtained values of probabilities. Each of states, like failure state of subsystems, can be defined with its probability. And we see that probability of good working state is high, but not enough, because the normative value of AC is 0.9999905. So, according to the Markov model of PLC availability simulation, increase of the failure rate of PLC subsystems can decrease its availability and its dependability. We saw that in 100 times. Our paper proposed an availability model for a large modular PLC of the latest generation, and it can be considered like network device inside IoT system. When constructing this model, mathematical apparatus of Markov models and method of system analysis were used. The study of the obtained model made it possible to calculate the value of the stationary coefficient of availability and its probability of being in each of the states. Obtained results of the simulation indicate that the PLC is a reliable system, and the probability of failure of its subsystems with initial data which we used is small. Our further study will about different impacts of factors on this system, and such like cyber attacks. Thank you for your attention, and we would like to say acknowledgement for National Academy of Sciences in Austria, because they support our research in the project of joint excellence in science and humanities. Thank you very much. Tell me, please, your questions.
Thank you very much, Professor Kalesniuk Marina. Thank you very much. Very interesting, your lecture. Please, have you any questions, please? Yes, Professor Alchenko.
Marina, thank you very much for your presentation. We had a lot of time discussing these topics. Thank you for your research. My question is about assumption for Markov apparatus application, because it's really it's not simple question. And in the framework of your report, you said about only failures caused by hardware. Yes.
In this model, we used failures caused hardware and also software with, and I have assumption about that primary errors has constant value, and also that secondary flow of secondary errors until the recovery, until the failure of software obeys Poisson distribution. No, in our research, Poisson distribution we assumed.
Okay, it's a standard approach, and concerning software, in this case, we understand that any design faults we can tolerate by restart of system. Yes, not changing of code.
Yes.
And application of patch and so on. Yes.
Yes, in my assumptions, I said about that patches or different recovery of primary failures doesn't use here. So we assume that number of primary errors is constant and without changing. So like static variant.
Okay, thank you. And one more question about maintenance procedure. I mean, you very detailed analyzed PLC structure. Yes. And
not very, because
according with your model, I think it's a very detailed model. You analyze different components of PLC. Yes.
Yes, it was structural analysis because before this research, I made analysis of structure, system analysis of structure of PLC, and also I made analysis of vulnerabilities on each of main components of it, and also like further research now. This is Markov model of availability because we use such subsystems that can be vulnerable, and our research like include some research parts without cyber attacks, with cyber attacks, and we compare how cyber attacks can influence on reliability of it. Now we use only failures of software and of hardware, and in further research also we use cyber attacks, we compare it, and we propose method how to use information about vulnerabilities, models of availability of subsystems in PLC, and also with using cyber attacks model, and we propose method how to consider all of this and to make recommendation.
Sorry, but it is your future research, and I understand your future steps. My question more simple. I mean, is it in practical issue possibility recovery components of PLC?
Yes, but all of these components can be recoverable, and we discussed it with producer of large model or PLC. No, for example, PLC Next from Phoenix Contact, and all of these components can be recovered.
Thank you.
Thank you very much. Any more questions, please? Okay, no more questions. Thank you very much.
Thank you.
Let's continue with the next presentation with the code ID code 4612 with Vitaly Zugalkov. intelligent control of electric flywheels, motors, units. Vitaly, are you online?
Hello, dear colleagues. Hello. Now I start the presentation. 1 minute, please.
Yes. We have 15 minutes.
Well, dear colleagues, let us bring your attention a report on topic intelligent control of electric flywheel motors unit. This report was prepared by Professor Anatoly Kulik, Dr. Konstantin Dergachev, Dr. Vitaly Zhulgakov, and lead engineer Vasil Petrenko, all from National Aerospace University, Kharkiv, Ukraine. And the report presents the results of theoretical and experimental studies of the fundamental possibility of joint use of deep diagnostics and flexible recovery procedures to ensure rational control of the operability of model unit of flywheel electric motors under various destabilizing effects. A rational control system has the following properties. Control is performed under conditions of uncertainty of destabilizing influences. Control is formed on the basis of knowledge about the properties of the elements of the system and possible destabilizations. In the process of control, deep diagnostics of the causes, places, and type of destabilizations is performed. And formation of control by diagnosis occurs as a decision-making process and includes the recovery of operability of the control system. So such properties of the rational control system allow us to consider it as a kind of intelligent control system. First of all, we want to present the complex approach to provide fault tolerance of rational control system. To describe abnormal models in accordance with the provision of automatic control theory, appropriate mathematical models are needed that connect the causes of destabilization with the consequences. Such models are called diagnostic models, and they have received appropriate development in a number of studies. So, to develop effective diagnostic models, we should perform such steps as failure detection, search of failure location, identification of failure class, and identification of failure type. As a result of these procedures, we have a diagnosis with required depth. Then the next stage is development the restoration support. In this way, we should choose different approaches, such as synthesis of signal tuning algorithms, synthesis of parametric tuning algorithms, control of algorithms configuration, and control of equipment configuration. So the further research based on this structure. First of all, fundamentals of rational control approach were considered on the base of block diagram of the system of rational control, or a system which performed control by diagnosis. So to the regular structure of the automatic control system, the unit such as diagnostic unit is added. And we divided the structure of control system to two parts or two subsystems as rational control object, RCO, and rational control device as RCD. And diagnostic unit is a hardware and software part inside the rational control device. So the diagnostic unit is the key element in presented block diagram. The purpose of diagnostic unit is to form a diagnosis of the rational control object. For this, it is required to detect the appearance of destabilizing effect, localize and identify it by searching for a place and defining a class and a type of the failure. So, electric flywheel motors, or EFM, are used to create control targets relative to the center of mass of spacecraft. Electric flywheel motors belongs to the class of inertial actuators of the spacecraft, which ensure the redistribution of the angular moment between the rotation rotor and the body of the apparatus. There are several redundant EFM placement structures. A pyramidal structure presented at the slide was selected for implementation and further research. This configuration was developed by General Electric Company. The block diagram of the pyramidal placement shown in the slide includes 4 electric flywheel motors, 4 flywheel angular velocity centers, or Tahoe TG1, TG4, and 3 angular sensors. The external view of the experimental stand with the EFM prototype unit placed in a gimbal is shown at the slide 5. The platform includes 4 electric flywheel motors placed according to the pyramidal structure. The platform is fixed in the 3-stage gimbal frames and can simulate the angular movement of the spacecraft. For each EFM of the prototype unit, a system is formed that provides both the control of the kinetic moment and the stabilization of the operability under destabilizing influences. Functional diagram of the digital system of rational control of EFM operability for one channel is shown in the slide. For the formulation of algorithms for diagnosing and restoring operability, mathematical models are required that reflect the transforming properties of the functional elements of the system. The construction of mathematical models is based on experimental static and dynamic characteristics of the units. A series of experiments were carried out on this experimental stand, and the appropriate characteristics of the elements were obtained. In the space of continuous states, the transformation of temporal signals into RCO can be represented by a system of vector matrix equation. After the appropriate transformation, the following system of discrete equations was obtained. Diagnostic models are the mathematical descriptions linking the cause of destabilization with its consequence. For the formation of diagnostic model, it is necessary to identify destabilizing effects that disrupt the operability of RCO. The experimental stand has the ability to simulate 14 types of destabilization. For example, for a power amplifier, the set of destabilization consists of such types as reduction of transfer factor, positive and negative drift, and break at the input wire. For electric motor, the set includes 3 types of destabilization, such as reduction in transfer factor, increasing the time constant, and break in the control circuit. And for Tahoe, the set includes such type of destabilizations as reduction in transfer factor, positive and negative drift, and break at the output wires. Really, the set of destabilization is not full, but it is a main destabilization effects which considered in the work. So for each of 14 types of destabilization disrupts the operation of RCO. To detect this fact, the reference model of the operation is used in the form presented in equation 4. With this model, a deviation signal may be calculated or generated according to the formula 5. Then the partial diagnostic model of elements of rational control object was created. For example, for power amplifier, such equation presented in the formula 6. And for electric motor, the diagnostic model will be in the forms such as 7. And for Tahoe, such diagnostic model as formula 8 will be were created. And such type of diagnostic model were designed for each of 14 types of destabilizations. So, according to the main provision of rational control, destabilizing effects are one-time undefined events. So, diagnosis is able only with the help of the procedure for searching for the specific type of destabilizing effect according to its scenes. The most adequate for the formation of scenes of destabilizing effects, as evident by the result of experimental studies, is the production model. In the production model, knowledge is represented by a set of rules, if-then, and to form the rules, two-valued predicate equations obtained from the corresponding diagnostic models are used. The procedure for diagnosing based on the scenes of the reason for the destabilization of RCO is formed in the form or dichotomous tree, presented at the next slide. So this dichotomous tree is used for searching of type of destabilizing influences in RCO. And with the help of diagnostic model, the arguments of the predicate equations are formed, from which the procedure for searching of the type of destabilization of RCO is constructed. First, the procedure starts with the predicate shown as equation 9. And in this predicate, we use some parameters as deviation of the signal from Technical generator because it is a main measuring device in the system. Tolerance for deviation, number of measurements, and confidence factor proposed by experts. To determine the RCO fragment subject to destabilization, the following predicate is calculated as expression 10. And for example, for power amplifier, scenes of types of destabilization can be detected using the following predicates, such as expressions 11. So the set of such predicates were formed for all of 14 types of destabilizations considered in this work. The dichotomous tree ends with leaves, which contain the estimated values of the parameters that characterize the magnitude of destabilizing effects. Estimated values are obtained from the corresponding diagnostic models after arithmetic mean processing. So for a power amplifier, we obtain such parameters which characterize the magnitude of destabilizing effects presented in expressions 12. both for electric motor and tachyon generator. Such expressions as CT were obtained. And in such way, for all parameters, these expressions were designed. So after the forming all parameters for dichotomous tree, we can develop the steps for restore repairability. So to restore repairability, redundant tools and means of putting them into operation, algorithms and programs for compensating for the consequences of destabilizing effects are needed. The experimental stand implements the simplest version of the use of excess funds, when each type of destabilizing effect uses its own tool for compensation. So, for example, for power amplifier, under the action of destabilizing effect, the reduce of transfer factor, its influences may be compensated by means of signal adjustment. And according to the expression 14, we can calculate the additional part of control signal to compensate this destabilization. For such type of destabilization as positive or negative drift, we can calculate the control signal, which includes the additional part for compensation, the drift according to its positive or negative value.
Sorry, excuse me, please go ahead quickly because we have time scheduled.
Well, I finished now. And in such way, we can calculate the additional control for electric motor transfer factor, and for such destabilizing effect is increase of constant time. So the approach is similar for all other destabilization parameters. And during the experimental research, we developed algorithmic aid software for the stand and perform the research for compensation of different types of the influences, all 14 types. For example, the compensation of the reduction in power amplifier gain is shown in the slide, and the main issue is that we can compensate by means of proposed algorithms. We can compensate the destabilization during the transient process, which is shown at the graph. And in the end of the report, short conclusions. So the results of the carried out studies confirm the fundamental possibility of deep diagnostic of the EFM control channel during the transient process, and the possibility of restoring operability before the end of transient process when simulating a number of destabilizing effects. The obtained results open up the opportunity to move on to solve new problems of forming a compact modular software structure for diagnosing and restoring of the operability of the entire EFM unit. And it also seems promising to expand the capabilities of diagnostic procedures with the necessary means of using signals from the spacecraft angular position sensor. Such use will expand the set of diagnosis destabilizing effects and increase the efficiency of obtaining a diagnosis. So thank you for your attention.
Thank you very much, Dr. Vitaly Julgakov, for your interesting presentation. We have very short time for discussion, for questions. Any questions, please? I have short questions. The title of your presentation is Intelligent Control. And decision which you presented based on tree of decisions, yes, but this decision tree is deterministic. And so my question is, where we talk about intelligence control, based on your model, your algorithm, and so on. Thank you.
Yes, thank you for the question. And I want to return to the beginning of our presentation. And we studied this question, and according to the recommendations of Institute of Engineers of Electronic and Electricity, the features of intelligent control systems based on the some parameters or some characteristics of the control system, and these features are uncertainty, operation under uncertainty of parameters, operation on the basis of knowledge, using of diagnostics in the operation process, and using of decision-making approaches. So we think that all of these features are used maybe in some decreasing, but used in the proposed approach. So we assigned the structure of the system and proposed algorithms as a kind of intelligent control systems. Of course, it's not a strong criteria, but such approaches are used in the operation of proposed system.
Okay, I understood that in this case we talk about cumulative effects, yes, and
yes,
factor we can say the intelligence control. Thank you. Thank you very much. I don't see other questions. Thank you.
Thank you. Thank you for your attention.
Dear colleagues, let's go ahead. We have a lot of presentations, and I would like to ask all of you about time schedule. Let's not more than 12 minutes. We would be better if we will time for more wide discussion. Okay. Our next presenters is number 9631. It's Kira Bobrovnikova, Sergei Lusenko, Oleg Savenko, and Ivan Kurman. IoT cyber attacks detection approach based on energy consumption analysis. Please, who will be present? Okay. Professor Sergei Lusenko, yes? You will.
Okay, do you hear me, colleagues?
Yes, we hear and we see you. Please, you have time for your presentation. Welcome.
Okay, dear colleagues, I'm very happy to be here. And unfortunately, my colleague, Kira Bobrovnikova, is unable to make this presentation, so this mission will be on my way. Okay, I'd like to briefly to present our team results concerning IoT cyber attack detection approach. And today it's a very interesting idea to make the detection based on energy consumption analysis. So of course, today, Internet of Things and smart home consumption have become an important part of modern society. On the other hand, the growing number of IoT devices, which are often released without any security features, make them a desirable target for cyber criminalists. So, since the limited battery capacity of smartphones does not allow them to be used for profit, that smart TVs, set-top boxes, and other IoT devices are popular with cybercriminals. In this regard, cybercriminals create new malware for these devices. As we can see, families of IoT malware are being detected recently. Also, unprotected IoT devices join the ranks of botnet that are most often used to launch DDoS attacks or as VPN exit nodes. Also, crypto mining is another popular way to monetize compromised IoT devices. The availability in security of IoT devices has led to a rapid increase of the number of IoT cyber attacks in recent years. Despite the large number of different developed methods for detecting and preventing of IoT cyber attacks, IoT devices is still incredibly vulnerable and suffered a wide range of cyber attacks. So there is a great need to develop new ideas, new approaches for malware and cyber attack detections. And today we'd like to present some ideas for detection based on energy consumption monitoring as a possible way to detect those performing attacks which require significant energy consumption. For example, DDoS, crypto mining, and so on. Okay. So we propose technique which is try to analyze the IoT device energy consumption. And to do this, I propose to organize and develop some footprints. And that footprints are based on a set of IoT users preference modes for some IoT device. Also, this model includes devices, set of devices in network, a number of devices. We have to define the energy consumption related to user prefers mode, such as temperature, lighting, humidity, air, quality modes, etc. And we deal with energy consumption control function, which keep up the energy consumption. We take into account current energy consumption and in certain mode and under the attacks. So idea includes two stages because it uses some machine learning algorithms. So it has learning and testing stages. So the learning stage of the energy consumption analysis includes such stages as footprints, construction for different related users preference mode in the absence of the attacks. The next stage, step of the stage, is we have to also construct footprints based on energy consumption in the presence of a cyber attack. Also, we have to normalize and label data. After that, we have to construct labeled and unlabeled data metrics for each IoT devices. And we execute learning of some classifiers. Later, we used several of them by using the labeled data metrics of the IoT devices energy consumption footprints. The next step, we have to test the classifier using unlabeled data metrics of the IoT device energy consumption footprints. And of course, we have to evaluate the efficiency of the obtained results. And to do this, to construct footprints of the energy consumption, we use some measures, and we have to normalize them for whole of IoT devices at the point in time at the absence of IoT cyber attacks, and as well as when we have such attack. And we take into account a number of measurements in some time interval. Here you can see the procedure of energy consumption footprint construction. Of course, it's based on the user's preference modes. Then we form set of devices which are analyzed. And for all of them, we have to construct footprints. taking it into account different user preference modes. And after that, we have to construct footprints based on absence of cybertext and its presence. After that, we normalize all data, and as the result, we have labeled data and unlabeled data, which are ready for its classification. Okay, and another idea concerning cybertext, when we take into account energy consumption, we have possibility only answer a question that is something is going wrong. Maybe we have an attack, but how to localize which exact IoT device is compromised and what maybe the point from what the attack is executing. So to do this, we involved another approach. So to do this, we propose action sequence analysis. So it's some behavioral approach in order to localize where exactly the DDoS, for example, text is performing. So to do this, also this approach has two stages: learning and testing. And the first one has such steps. The first one, it's assembly representation extraction for the benign and malicious IoT binary executables. After that, we have to represent actions as maximal sequential pattern mining in all the binary executable assembly. After that, using that patterns, we are able to construct feature vectors. And after that, we are eager to evaluate the relevance for each of the selected maximal sequential patterns. And the next step is to perform labeling and construction of feature vectors of actions of every maximal sequential patterns relevance to each binary executable assembly representation. After that, we are able to construct label and unlabeled data metrics of the feature vectors, and to do this, we can use different classifiers using that obtained matrix. And the next step is to test classify using unlabeled data metrics of feature vectors of the maximal sequential patterns. And after that, we have possibility to evaluate the efficiency of the action sequence analysis. Okay, to do this, here you can see some mathematical base of maximal sequential patterns concerning our feature vectors. And here some math concerning how we can evaluate relevance for each of the selected maximal sequential patterns. To do this, we can use mutual information, frequency of each actions, type of class which is executed, and also we use joint probability distribution function, and as well as marginal probability distribution functions to calculate that needed relevance. Okay, here is sum up of the steps. We are dealing with benign, set of benign and set of malicious binary executables. After that, we perform assembly representations for each of them. And after that, we use MSP for all of them. After that, when we obtained its value, we can sort them, evaluate relevance, and obtain future vectors. Based on that, we are eager to obtain labeled and unlabeled data for its further classification. Okay, the most important part of the research, of course, it's efficiency assessment. So to do this, we used a set of classifiers. We used some measures as accuracy and as well as F1 score. And so to do this, we tried decision trees, a random forest, nearest neighbors, and extreme gradient boosting algorithms in order to make classification. As you can see, we have three types of the research. When we applied only the energy consumption analysis, when we use only software behavior analysis, see the efficiency is pretty low. When we use only the energy consumption analysis, when we use only behavioral approach, results is about 80%. But when we combine both of them, when we can, using the energy consumption analysis, find out that there's something is going wrong, yes, and taking into account what behavioral analysis, we obtain very good results for this. So you can see two part of results of accuracy values as well as F1 score values for these results. And as we can see, also combination of two approaches. We are talking about energy consumption and behavioral analysis, and demonstrates very good results. So here you can see conclusions, but I'd like better to hear your questions. Thank you for your attention.
Thank you very much for your presentation. It is one of the directions how we can get additional information to more accurate detect cyber attacks. And now we have short time for questions. Welcome.
Well, I've got one question, Alexander.
Alexander, welcome.
Well, it would be interesting to know if you considered peculiarities of assessing wireless IoT products energy kind of measurement, because, as you know, radio brings a little too big uncertainty into power management and power assessment. So it will be interesting to know if you looked into that as well.
Actually, not yet, but thank you for a good idea. Yes, because yeah, wireless technologies, it's a great part of the IoT infrastructure, and yes, we have take a look at that part, but we didn't do it yet. Thank you for your idea for our next level of research.
Thank you for question and answer. Any other questions? No. Thank you very much. One more for your interesting presentation.
Thank you, colleagues.
Thank you. Okay, let's go ahead. Dear colleagues, I sent information about order of our next presenters in chat. Please, I would like to welcome for presentation our colleagues from Ternopil, West Ukrainian University, Dr. Osolinsky.
Good morning. Hello, everyone. I'm ready to present my work, but was tiny problems with electricity. Present only according my articles. Can I present it?
Yes.
Okay. You see my presentation?
Yes, Alexander, we see and we hear you. Please,
Okay.
12 minutes for your presentation.
Okay. The main idea of this work, it was the methods of energy for measurement energy consumption by microcontrollers, and why we do it and why we analyze it, because today if we talking about only power consumption energy by microcontrollers, it's not correct, because today more correctly talking about energy consumption of all embedded devices, not only IoT. It can be power consumption of, for example, when data logging or data transferring, because many of these operations executed by microcontrollers, and analyze and select the methods for energy consumption for this task is urgent task. And in my work, divided to 3 big parts. In first part, we analyze in generally how to decrease the energy consumption. It's classical method. It's decrease clock time, decrease clock, or decrease, for example, frequency, and we get some profit with in power consumption. We analyze, for example, what will be if we decrease, for example, frequency, or if we decrease power source, for example, voltage, and it's one part, and its part can divide, can get profit about 50% with energy consumption by microcontrollers or another microcontrollers units. It can be, for example, from tiny Arduino for some smart energy counter. Yes. And on next step, we analyze the methods of how to measure current and how to measure power consumption. And on first, we analyze the classical method. It's which shown on figure 4. It's that method shown in many articles. It's shown in official site of Arduino, for example, and in other sites for another microcontroller units. We can find this methods too, but that method it's not good because we have a direct connection and we have tiny current, and it's not possible measure current in high precision level. And for next and our next step was analyzing the interest systems which call it source measurement unit. It's more advanced devices which you can connect, for example, your device, which will be tested, and test how many current consume this device too. One moment about these devices, that devices is not cheap and not all researchers can get this method, this device, because it's expensive things. Another methods which I analyzed that it was it called it tracker of energy consumption, and that method in this method we measure not we in this method measuring the charge discharge of battery on microcontroller, and all these methods it is side of microwatts and microamperes. But if we're talking about power consumption in all IoT industry, we need to remember about high performance computing, where for example, where are operation on graphical processors, and for this, if we see on this side, in this area, usually using current sensors, and you can measure not only micro current, but we can measure current on GPUs. Yes, for analyzing, for example, data transferring or data logging or another. But all these methods, previous methods, it was methods which are connect to a device which investigated, yes, but is are another methods. It's not contact methods for measuring, and that methods, not contact methods, we can divide on few parts. It's measuring current on optocouples, or measuring current on digital isolation. And that methods and devices more interesting for my research, because it's not contact, and we not include any extra signals into measuring process, because measuring part and device under research is divided by some physical environment. And I proposed concept of measuring system for analyzing of current consumption by smart devices. It maybe for graphical processor units, and this concept includes few parts. In this system must be system measurement unit, and must be not contact current sensor. And after that, we can get two parameters. First, from measurement unit, and second, from non-contact current sensor. And after that, we can analyze power consumption. And for example, get optimal review how must work some IoT device for longer for long time without recharge batteries, for example. And about conclusions, we have some results, and all this, if we try to analyze IoT devices or some smart devices, or the first what we need to do is divided these devices before analyzing, divided for some groups, because new devices anytime we have new versions of IoT devices, new models, and for this need do deeper analysis of this field for divide IoT devices for some specific groups for analyzing. For example, one group we can analyze by contact methods, another group can analyze only non-contact methods, and in this concept, we can do this without implementing many measurement devices, because if we have non-contact or we have, for example, IoT device which can measure only by non-contact methods, we can use this concept. If we have device where we can use contact method, we can use this concept too. And it's finish of my presentation, and thank you for for your attention. And I'm so sorry that I not have presentation, and thank you for your attention.
Thank you. Thank you, dear colleagues. Any questions now?
Alexander is here. Can I have a question? Thank you for the great presentation, Alexander. Two points that I would like to know and actually recommend you to look into is actually spurious power consumption assessment. Because in IoT products, especially the wireless ones, what is most important, what I see in the industry is that you actually assess the power patterns, not only the absolute values, but the way power is used. And there's one of the small hints also is to use super caps as pretty predictable energy sources to make the assessment of the power consumption used by the product. So I don't know, have you looked into this method of power consumption assessment or not?
About super capacitors?
Well, super capacitors and also the spurious power consumption problems.
No, I not see on this field.
Okay, thank you. I think it would be really good good evolution of your work to assess that topic, because it's really a troublesome part of this research, I think. Thank you.
Thank you very much for your questions and answer. Thank you, Alexander.
Thank you too.
And our next presenters, please, number 1742. I search presenters. Is Mikhail Kvasny, Vladislav Shevchuk, and Halina Klim. Is here? Okay, and one more presenter of our section. Marina Derkach, Danila Matyuk, and Inna Skarga-Bandurova. I saw that Danila Matyuk will.
Yeah, thank you.
Oh, Danil, sorry. Can you now present your?
Yeah, okay.
Okay, welcome.
Can you see the presentation?
Yes, we see, and welcome for your presentation. Please 10-12 minutes. Okay, thank you.
Okay. Today I'd like to present our result on developing autonomous quadrilateral flight stabilization system. So you can see the topic here. First of all, we're going to discuss our motivations that raise it not only from our desire to achieve an effective autonomous stabilization system, but also from our analysis of state of the art in area on small multi-robot drones. Then we talk about the objective of the research. We will also show a case study and main results from a real assembled quadrilateral. And finally, we make some conclusion and feature on next steps toward developing experimental quadrilateral configuration. So let's start. Recent years, small multi-rotor drones are great interest in science. They're light, maneuverable, and relatively cheap. However, due to their simplicity and low rotor redundancy, quadrilaters are also more challenging to stabilize, especially in the gridded environment or when external controls, such as GPS, are denied or unavailable. For this reason, we denied that effective autonomous quadrilateral flight stabilization system requires a good solution for the following task. First, it determines the position of the quadrilateral in 3 planes, the angle of inclusion relative in the Earth's surface, and calculates the deviation from the required position. And 2, it's apply control signals to compensate for the deviation and bring the quadrilateral to the required position during the proportional integral derivative control, its speed control. So we start from primary analysis of state of the art and the topic of autonomous flight stabilization of small multi-rotor drones. Some paper with the most prominent result are presented in this slide. This work aims to develop an effective autonomous quadrilateral flight stabilization system, science both the PID controller, the complementary filter, and easy to implement. The stabilization system based on them and less resource intensive, and this is an important nuance from working with low power quadrilaters. The PID controller calculates deviation compression and brings the quadrilateral to the required position. The complementary filter is used to improve the accelerated tilt angle calculation relative to the ground. Our next slide includes result of solving full subtask, the design of flight stabilization system based on the complementary filter algorithm and PID controller, experimental configuration of the quadrilateral and testing result. Figure shows a block diagram of proposed flight stabilization system based on the PID controller and a complementary filter. The PWM level controls the rotation speed of the motors X, Y, and Z, the specific angle along the X, Y, and Z axis, respectively. A signal is applied to the microcontroller, which is converted into pulse-width modulation, its PWM signal. The correct angle is determined using a complementary filter which calculates and sends an offset to the PID controller. The PID generates an output signal in form of a PWM signal to maintain the set position. The PWM implementation, the controllers consist of two blocks, is a linear integrator and three position relay elements. Science for flight stabilization, it is necessary data time of orientation of the quadrotor along the three axes. It's necessary to calculate the angles of inclusions using accelerometer and the rate of change of the angle due to the gyroscope. By processing the angles of the three-axis gyroscope according, one can obtain the orientation of the object in space. By measuring the acceleration of the three axes of the accelerometer, linear accelerometer data can be obtained that is possible to determine the movement and fall of object or the push against an obstacle in order to bypass it. To calculate the deviation compression and bring the quadrotor to the required position when solving the problem of flight stabilization, a PID controller is used. When stabilizing, all three axes must be taken into account normally, its roll, pitch, and yaw angles. Direct control is carried out by calculating an amount of effort with which the quadrotor tries to compensate the angles of deviation and each iteration of control period. The proper stabilization system was tested and validated on real assembled quadrotor. The components were used in the development of the quadrotor are present on slide. For convenience, a double slide printer curved board was made using laser ironing technology in sodium persulfate, which is usually used to each printed circuit and copper. The board is based on STM32F4 family microcontroller and has a specific groove form shape to be placed on specific frame model. Their sizes board correspond to the dimensions and quadrotor chassis, which also made it possible to place all the necessary components on it, thereby reducing the number of wires to a minimum and avoiding the additional servo board. The MPU 6050 has a programmable interput system that can generate an interput signal on an INT pin, which generates a pulse every time the state of the pins change. In figure, pin A11 is responsible for clocking the I2C bus, pin A12 is for data transfer, and pin A15 is used for implementing an interput to fill the memory buffer in MPU 1615. For data exchange between STM32 microcontroller and GI521 model, we developed a method for connecting device via the I2C interface. Verification of the development method for reading data from the sensor register and performed as follows. Interput occur about 45 times per second. Each interput lasts about 22 milliseconds. 14 sensor indicators are processed and in one input, respectively at address. The gyroscope reading are discrete signs. They were integrated a microcontroller to determine an angle of deviation from the initial position. The method fully mimics the operation of the sensor without loss of data accuracy and less costly quadrotor configuration. If such need areas, it is possible to increase the number of devices using free contact of the microcontroller without loading its memory, thereby simplifying calibration in case of orientation error and quadrotor flight stabilization. This slide shows the result of reading of the GI521 model when applying 10% of the power of the quadrotor engines. Due to the issues discussed about the reading, all the tilt angles for the test period are destroyed. As RMSE values are 36° and 16° for the gyroscope and accelerometer respectively. For clarity of the results, sensor data from the quaternion position, which used the gradient descent orientation estimation filter to describe the position of the body in space, is transformed. Table 1 shows that after the conversion, the obtained values as 39° for the gyroscope and 18° for the accelerometer. After processing by the filter, the value of RMSE equal to 3° was obtained, and through complementary filters, the error was 2°, which means that both filters give very accurate angle and unconditional of shaking and vibration. The result of the complementary filter is shows the figure sensor reading from a quadrature. The green line is the angle computed from the gyroscope reading. Gyroscope is subject to zero offset is stability, and which until 0 point on the gyroscope drift in time through the integration of the state of the position angle. That is, the error is integrated. As a result, the angle gradually increases. The red line is the angle according to the accelerometer. Over time, an external force acts on the sensor, which introduces an error in computing the angle of inclination. The blue line demonstrates the angle computed using the complementary filter. And therefore, they condense of the red and blue curves. The point where blue curves begin to fluctuate means the state the pit controller, which tries to compensate for the deviation at quadrature from the horizontal plane. When establishing, we need to take into account L3 axis, adding a pit controller for not only the roll edge, but also for the pinch and yaw angles. In figure, blue line indicates the quadrature's deflection angles, and red one indicates the effort the quadrature tries to return to the side position. Now a short video about how the first testing in the project took place. Okay. As a result of testing, the developed stabilization system confirms the possibility of its use in the construction of a quadrocopter. Two main tasks have been solved in the development of a flight stabilization system. Firstly, the position of the UAV and free planes is determined, the angles of inclusion relative to the Earth surface, and the deviation from the required position are calculated. Secondly, control signals are given to compensate for the deviation and bring the quadrocopter to the required position. Thank you for your attention.
Thank you, Daniil, for your presentation. Dear colleagues, any questions now? I see. Dr. Igor Kryushnikov, please.
Good day. Thank you for your presentation. My question is, do you consider in your devices case when one of engine of UAV failure? In this case, can this UAV fly over with this situation?
No, I haven't tested this situation.
Thank you.
Other questions? I have very short questions. Do you take into account in your experience, in your research, failure issues of components of UAV? I mean, influence of such failures on your system of stabilization?
Yes, of course, and on this basic, I regulate the coefficient for PID controller, and it's be many test and choice the better coefficient.
I see. Hence, you take into account this issue by checking of changing your parameters, yes?
Yeah, coefficient is more actually for setting stabilization. It's
Yes, I understand that is a parameters which can change it caused by failure, yes? And you check this coefficient or coefficients, and by such way you can check failures states as well. Similar one of the our previous presentation where this idea was demonstrated. It just not maybe question, just discussion issue. Okay, thank you very much, Daniel, and your colleagues for your presentation. Now we have the last presentation. We can ask as a author. If not, we have video presentation. Do you see this presentation? 1 minute. We share our screen. Yes. Yes. Do you see our screen?
Yes, yes.
Yes, please see this video.
Sorry, broadcast windows without sound. If you choose translation, yes, checkpoint for the sound.
Sorry, we try repeat this part. What about sound now?
No sound. You can try broadcast one, not L from, only one taps.
Now we have sound but not have video.
Video C and no sound because broadcast choice on L from, but you need to choice in one tab with this video.
Okay, we will try.
Of the expression in time, and as well as being tied to areas, since all data is taken from static stations.
Now?
Everything is okay.
The main idea for the information collection platform is planned to create several components at once. The first one, a complex of sensors for data collection. Second one, a drone with the possibility of direct control. Third, automatic data collection system based on given coordinates. Fourth, GSM communication system. Fifth, the system for transferring the collected data to the server. Proposed to develop a system that will allow collecting, processing, and storing weather indicators of a limited area of the territory in real time for universal drones. The system will rely on data collected from drones and have the possibility of configuration and scalability depending on the needs of the user. A relational database is used to store the collected data, however, a real-time database is used to correctly display the collected data in real time. Integration with the Open Weather Service allows to compare collected data for areas where it possible. Other configurations are available on the application. Structural diagram of the design system. On the left is a roller scheme of the system. There is a UAV that has access to the server. Access is carried out through the GSM module or through a wireless access point. The user has the opportunity to control the drone through the web application, send him the necessary coordinates, and collect the related data, either directly by connecting to the drone or a wireless access point. In this case, control is carried out using a controller. On the right is a general scheme of saving and outputting information. Accordingly, we have several platforms, not necessarily mobile or even drones. The data is transmitted directly to real-time database, after which is displayed in the web application. In addition, through the application, it's possible to transfer additional data to the information collection server. In the future, the data is stored in a relational database. Other components. The core of the system is ESP32, which has a large number of interfaces and supports many data transfer protocols. It's quite cheap and powerful. The basis is a F450 frame, which is simple. It can even be printed on a 3D printer. To control the motors, the BLHE-LY 40 ampere speed controller and the Sunny Sky X2212 motors themselves are used. GPS Neo 7 is used for orientation in space. The HC-SR04 ultrasonic sensor is used for automatic star delivery. The GSM SIM 800C model is used to connect to the database without access to the internet. The MCU 9255 sensor is also used, which includes a 3-axis gyroscope, a 3-axis compass, and a 3-axis magnetometer. It's necessary for the orientation of the drone. The BMP 680 sensor is used to collect the data itself. It measures temperature, humidity, pressure, air quality, and relative attitude. Basic technologies. It includes Firebase and or relative. For example, Firebase real-time database, default relative database, Firebase notification. Also, for creating web application was used Angular and integration with Service OpenWeather. Also, Cypress was used for E2A testing. The main advantages of the design system. The main advantage of the system is low cost compared to analogous, due to low cost of used drone and system components. Big potential for modernization. Also, the system supports a lot of security features. For example, IEEE 802.11. Also, it has flash drive encryption and cryptographic acceleration. Also, the system have the ability to set truth points and specify the date and time when you need to collect data through the web application without the need to be near the drone. The main advantages of the outputting system. Modularity. The whole system consists of several modules which can be parts of other modules. Thus, the system can be fast modified. Scalability. The system is designed for several users to be able to accumulate their number without significant cost in speed. And universality. The system is not tied to the model and configuration of the drone. For this operation, it's enough that the latter corresponds to a limited set of parameters and will be transmitted. In addition, the system able to identify a user who can or cannot provide data from a particular drone. Possibilities of improving the system. We can add the video model so the user can control the whole process of collecting data. We can use LiDARs, more powerful GSM model, and use STRAT technology. With this technology, we can use even a few or a group of different drones to collect the whole data. If I talk about web part, we can expand the number of simultaneous users, drop attachments to display data, improve administration, and deep integration with OpenWeather service. Workbench with drone components. On the left is a frame with the motors and speed controllers. On the right is a mock-up board with placed components that are used in the drone. Intermediate work result. On the left is an example login window where you can log in by entering your username and password. In addition, you can use Google services for the same. If the user is not registered yet, he can do so on the same page. After authorization, the user will see a page with information about him inside the system. For example, his login, ID, role, etc. Depending on the role, the user will have a certain level of access to some data. All data will be linked to the unique identifier of this user in the future. After clicking Navigate to the data dashboard, the user will be taken to a page displaying data from his platform. Once the user navigates to the data page, it will display metrics collected in real time from their platform. In addition, there are interactive cards that display current information about various cities of Ukraine. It's taken from the OpenWeather service. There is also an opportunity to upload a file with coordinates for the automatic departure of the drone. On the left is an example of a web part hosted directly by the board when in direct control mode. It's showing the current state of the user controller. Window with data from real-time database. As you can see, user have at least few main fields. This user unique identifier and user roles. By this, user can access their data. If he don't have any of role, like reader or admin, he will not have any access to any kind of data. Also, the whole data stored by the same path as user, including user ID, so even data or user data can be moved to another space. Example of data which is sent to real-time database from the autonomous platform. Board was connected to the computer. The data on the screen is what is output to the COM port via USB. So you can see they are delivered temperature, pressure, approximately attitude, humidity, also indicators of the gyroscope, accelerometer, and GPS module, where the route is laid according to the coordinates. So you can start from, for example, London and end at the some in another part of London, or etc. Application. You can use a Google account or register and log in using a login and password. Let's look as a prepared user. In the database, we can see the corresponding user with the same user ID. Let's move on to the data itself. In the fields, we can see the data coming from the autonomous platform. We can also observe interactive cards with different cities of Ukraine, some facts about them, and the weather. The latest is taken from the Open Weather service. We can also upload a file with coordinates for a drone flight to the appropriate location. So wait a little bit for data updates in the database and enable auto scroll to demonstrate incoming data. An example of control system. The board hosts the site to which the controller is connected. When clicking the corresponding button, we can observe a change in the color of the corresponding button on the website. If you move the flow, you can see that axis change. Drone prototype. Thank you for your attention.
Thank you our online video presentation. Sorry, we cannot ask others concerning any questions of this presentation. Dear colleagues, if you have any questions, please send questions directly using mail or via organizers of this conference. We will resend your questions and resend answer. Okay. Thank you. Dear colleagues, we have good result of work of our section. We finished and discussed six reports. Thank you so much all presenters, all participants for question discussions and so on. Short information concerning our next steps. At 2 p.m. Greece time and Ukraine time as well, we will continue our work. And the next activities, it's plenary session number 2 with 2 very interesting presentation on application big data analysis and big safety issues from Ukraine and United States. Welcome to our next plenary session according with schedule. Hence, we will start on this place 50 minutes later. Any questions, please? No, thank you. See and hear 50 minutes later. Thank you.